Hello, good day viewers. In this tutorial, we are going to find a solution to this exponential equation. We have x to the power of x root x equal to x root x all to the power of x, and we are only looking for the real values of x. I'm going to present you two methods. Let's get started with the first method. All right, before we start, let us look at the domain. You can clearly see that from left to right, x must be greater than 0, right? It's a positive number greater than 0 because x here cannot be equal to 0 because 0 to the power of 0 is undefined. So x must be greater than 0. So let's get started. Let us first of all simplify x root x. And we still have another x root x here. If you have x root x, this is always equal to root x cubed. Why? Because you know x can be written as square root of x squared, right? Square root of x squared, where power of 2 will cancel the square root. So we can multiply by another square root of x, where we can simplify this as x squared times x, which is x to the power of 3. So we have square root of x to the power of 3. And your square root of any number can be expressed as a power of 1 over 2. Lastly, we can write this as x to the power of 3 divided by 2. So we are going to replace this with x root x. Therefore, we can express this as x raised to the power of x to the power of 3 over 2, for which x to the power of 3 over 2 is the same thing as x root x. Then to the right hand side, we have x to the power of 3 over 2, also raised to the power of x. And from law of indices, we can multiply these powers together. So we have x raised to the power of x to the power of 3 over 2. And this is equal to x to the power of 3x divided by 2. Observe, we have common bases, and we know that the bases are not equal to 0. Therefore, we can equate the exponents. So x to the power of 3 divided by 2 is now equal to 3x divided by 2. And you know we can raise this one to a power of 1. Now we can multiply their corresponding powers with 2 in order to eliminate this 2 down here. So let's do that. We multiply this by 2, we multiply this by 2. So to the left hand side, we have just x to the power of 3. And to the other side, we have 3x divided by 2 raised to the power of 2. Let us expand the right hand side. To the left hand side, we still have x to the power of 3. To the right hand side, you know this exponent is going to affect numerator and denominator. So to the top, we have 3x times 3x, which is 9x squared, divided by 2 times 2 equal to 4. Now we can divide both sides by x squared in order to eliminate x to the right hand side. So to the left hand side, we have x to the power of 3 divided by x squared. To the right hand side, we have 9 divided by 4 multiplied by x squared divided by x squared. Remember, we know that x is not equal to 0, so this is gone already. To the left hand side, applying one of the laws of indices, we take a base, which is x. 3 minus 2 is 1. So to the left hand side, we have only x. And to the right hand side, we have 9 divided by 4. And this is the solution to this problem. Now let us apply the second method. Let me take log to the base x, because we know x is not equal to 0. So I can say that take log to base x of both sides. We have to do it to the other side as well. Applying one of the laws of logarithm, this power directly can drop down to multiply. So we have x root x to the left hand side multiplied by log of x base x, which we know is equal to 1. This is equal to, this x can also drop down to multiply. We have x multiplied by log of x root x base x. This is already equal to 1, so it is gone. To the left hand side we have only x root x. To the right hand side we have x multiplied by, we can split this product because we have x multiplied by root x. We can write it as log of x base x, then plus log of root x base x. We all know that this is also equal to 1 log of a number having the same base as the number. And you know that root x can also be written as x raised to the power of 1 over 2. So that 1 over 2 can also drop down to multiply. So let's simplify further. To the left hand side we have x root x. To the right hand side we have x in the bracket 1 plus, and we can even bring it directly, 1 over 2 log of x base x. Log of x base x is also equal to 1. To the left hand side we still have x root x, and to the right hand side we have x multiplied by 1 plus 1 divided by 2. Now let us distribute x. Or we can divide both sides by x, right? We divide this by x, we divide this by x, such that this x will take care of this x, this one also take care of this. So we only have root x to the left hand side, and to the right hand side we have 1 plus 1 over 2. But 1 plus 1 over 2 is the same thing as 3 over 2. So root x is equal to 3 divided by 2. To find the value of x, we can square both sides. So if you square the left hand side, you will be left with only x. If you square the right hand side, you have 3 squared 9, 2 squared 4. And hence this is the solution to this problem, x equal to 9 over 4. You can see in both methods we have 9 over 4. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. For your assignment, I want you to test this value of x, 9 over 4, in the main equation to see whether the left and the right hand side are exactly the same. Bye bye.